Okay, so it's in quadrant 2. We're back to our usual business. There we go. It's in quadrant 2, which means it goes out there. And since it's cos, it's x over h. So the h has to be 2, which means the x has to be negative root 3, which means that has to be 1 to make that triangle. Find the exact values of the remaining trigonometric ratios. So sine is 1/2, tan is 1 over negative root 3. And the value of it, this has to be 30. If this is 30, what's theta? 150. Now, on a test, I don't need to see the drawing if you can do this without drawing. That's not going to be needed. But let's say you got all 3 of these wrong somehow, but you drew it correctly. Maybe you said theta was 30. And maybe you said you reversed these. You did 2 over 1 and root 3, negative root 3, whatever, something like that. If you got all that wrong, but you had the drawing, I'd still give you some credit. Everybody understand? Even on the 1, 2, 3, 4 scale that is coming for you before the end of your life, you would still get probably 1 even for having the drawing, because that shows a lot of understanding, yes? Okay. Over here, it's in quadrant 1. Tan is 1, so that is 1, 1, root 2. So cos is 1 over root 2. Sine is 1 over root 2. And theta is 45. Everybody good? Oh, and I would have scored these at 3 each. Okay? Everybody remembers how to do this now? All right. Quadrant 4, it would be down here. It's sine, so you know that's root 2, so you know that's 1 and 1. Since you're out there, that has to be negative 1. So cos is 1 over root 2. Tan is negative 1. And if this is 45, what's theta? 315. I heard someone say it through their yawn. Tan is root 3. It's in quadrant 3. This quadrant always screws you guys up. Well, not you guys, because you're smart kids, but previous classes are always screwed over by quadrant 3 because tan is positive, right? And it messes you guys up because you don't remember that this is negative and this is negative. So this is negative root 3. This is negative 1, right? What? Okay. So this is 30. This is 60. Now, everything's fine to here, but when you do the sine and the cos, you kind of mess this part up. Sine is negative root 3 over 2, and cos is negative 1 over 2, and theta is 240. Tan being positive, everyone forgets that the 2 negatives make a positive. Okay? Making that whole page out of whatever it was out of 12, I guess. Exact value of each, so that's sine 135, right? So that is 45 is the triangle you're going to be using, yeah? And since it's 135 and it's in quadrant 2, it must be positive. So it's 1 over root 2. This one is tan 120. That's 60. It's negative. So it's going to be root negative root 3 over 1. So just negative root 3. All these would be 1 each. Do people need to see how I'm getting this? You need that reminder? No one? Okay. So cos 150, that's 30. So that's 1 over 2, negative. Tan 210, that's 30. That's positive. That's going to be 30 there. So that's 1 over root 3. All these are 1. Cos of 300 is 60 down there, which means that's 1 over 2. And 225 is 45, so that's going to be negative 1 over root 2. Oh, I'll come back to some. Remind me to talk about that in a second. 210 is 30, so that's going to be negative 1 over 2. And 30 is going to be, oh, that's on that side. So it's going to be 31 over root 3 negative. These guys right here, technically we don't want to leave a radical on the bottom, right? I'm perfectly happy with this, but that numeracy thing that you're getting that's coming towards you may not let you leave answers this way. I can't see the future, right? So, of course, this is technically negative root 2 over 2. Technically, because you would have rationalized this with root 2 over root 2, right? Technically. But I'm perfectly happy if you leave it this way. Does everybody understand? Everyone's okay with that? All right. And that makes that page out of, I don't know what it was out of. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Making that whole thing out of 22. Did I collect the last assignment, Mark? I don't know if I did. It's only 8 on there? One, 2, 3, 4, 5, 6, 7, 8. Yeah, it's only 8. Sorry, so it's out of 20. Okay, you don't need to write anything down. You just need to look up here right now. Those of you who are either A, from another country, or B, were in my Math 10 honors class, already know what I'm going to do here. So you have to kind of like just relax for a moment. If you were not from another country and you were not in my Math honors 10 class, then you need to pay very close attention to what we're doing here, because not because this is particularly important, but this is why what we're about to do works. Okay? So looking at that triangle right now, can you do trig on it? As it is drawn right now. Yes or no? You say no. Why? There's no 90-degree triangle, right? Everybody agree? There's no 90 degrees in this triangle that I have drawn here. So we cannot do trig at the level which we have been learning trig. Everybody's cool? Okay. Let us then, since we have a triangle here, and since we know trig deals with triangles, and since we know that every triangle in the world is not necessarily a 90-degree triangle, there must be a way to do trig with this, right? And of course there is. What is something I can do with this triangle in order to be able to do trig? I can split it in two, right? If I draw this red line right here, what have I just made? Two 90-degree triangles. Does everyone agree? Okay. Now, if we did that, and we knew that this, which I'm going to call Q. I'm just calling it that because we don't know what it is, yes? I don't want to call it H for height because then that messes people up with hypotenuses. Okay? Everybody cool with what I've done here? Now, could you do some trig on the left side here? If we had numbers, could we do trig there? Yeah, because we would know red theta, green theta, we could do trig. Opposite over adjacent, adjacent over hypotenuse, all that stuff, yeah? Everyone agrees? Okay, so if I were going to do some trig here, I'm going to use this red theta, all right? And what do I know about theta here? I know that, for example, Q equals what? What kind of math can I do? What kind of trig can I do to find what Q is here? If I need to put in numbers, I can put in numbers to help you, if that will make your lives easier. Do I know what this is? Just, Do I know that? No, because C goes all the way across the bottom, correct? Okay. Do I have that? What's that? A. So since I have A and a theta, that's a hypotenuse. What is Q compared to my theta? Is it opposite or adjacent or hypotenuse? It's opposite. Everyone agrees? Okay. So what trig ratio can I use to deal with the yellow line Q and A? Sine, cos, or tan? What can I use? Sine, because I have an opposite and a hypotenuse, yes? Does everyone agree? Okay. So Q equals, now, if you're not able to do this in your head, let's go back a step. Sine theta equals Q opposite over hypotenuse. Everybody agree with that? Q is opposite, A. Everybody good? Okay. So now, over on this side, what can I do on the green side where I have put this theta? What can I put there? What can I do with that? Sine again, right? So over on this side with blue theta, the sine of blue theta equals what? Q over B. Does everybody follow what I have done so far? Everyone agrees? Okay. Now, you guys are smart kids. What do you notice about that and that? Q is in both of these, isn't it? It's the same in both of these triangles, yes? Is theta the same in both triangles? No. Are A and B the same in both triangles? No. Only Q is the same in both triangles. Everybody with me? Okay. So since Q is the same in both triangles, let's solve these equations for Q. Everybody understand? So when I say solve for Q, that means we get Q isolated, correct? So what do I need to do over here to get Q by itself? Talk to your neighbor if you can't remember how to do algebra. I'm going to multiply both sides by A, yes? So sine of red theta, and I'm going to do this side in red. I should have done it that way. Sine theta times A equals Q, yes? Everybody with me? Okay. What is it over here? Sine theta times B equals Q, yes? Now, you guys are smart kids. If that equals Q, and that equals Q. What do you know about those two? They're the same. So I can write sine of red theta times A must equal the sine of some things never change. Sine of blue theta times B. Is everybody with me? Yeah? Okay. Now, if I wanted to name these thetas, right? What letter would I write here? What kind of A? A big A. And what letter would I write here? A big B. So I can change this to what? Sine B, right? I can change this to sine B times A equals sine A times B, correct? Everybody still with me? Okay. Now, watch. If I try to solve these now, if I want A, what would I do? Actually, hold up. I'm going to wait a second here. You see that Q works for both of them, yes? Everyone agrees? That Q must be that, Q must be that, so those two have to be the same thing, yes? Everybody good? Okay, so since you can see that these guys multiply together, if we were going to do algebra with them and have to solve, what would we have to end up doing? If I'm going to do algebra with these multiplied things, what am I going to end up doing? Division, right? Everybody with me? So, according to what you guys know now, seeing it on a triangle, I'm going to ask you to be writing stuff down in a minute. I'm going to go back to our notes. You know there's going to be some division involved, yes? All right, so this is what we call the sine law. This is good for, and I'm going to highlight, triangles that do not have a right angle. Whenever you are faced with a triangle without a right angle, this works. And I just drew it out to explain why. A, B, C. What does that make this side? Little a, what does that make this side? Little c, what does that make this side? Little b. Now please look up here. This works. That's what we just proved on the other page. And I didn't need you to write it down because you didn't need to see it proven. Or you didn't need to know what. You didn't need to be able to explain why it worked, but I needed you to see how we get to here. Okay? Once we are here, you can fill this in. Now, please notice that you must have one of the pairs for it to work. Okay? So, right now, we only have letters. Everybody cool? Why are you binging at me? Everyone's good with the letters? Let's put some numbers in there. I'm going to draw it again. A, B, C. And let's put in some numbers. It doesn't really matter what the numbers are. Let's call that 93. Let's call that 47. Then what does that make this? $40. Everybody cool? Everybody good? Okay. So now, let's make this 18. Let's make that 13. And let's call that little a. Does everybody see how this information would work in here? What would I put for little a in here, from here? It's got to stay as little a. What would I put for big A? 47 degrees. What would I put for B? 18. What would I put for sine B? 93. What would I put for C? 13. What would I put for sine C? 40. C. Is everybody cool? And then that gives me all these fractions. Now, do we all remember how to do algebra with fractions? Everybody? Like if I gave you this, you can solve that. You all remember how? What do? Cross, right? Now the only difference is instead of this being 7, it's the sine of 7. So what would you do? You would still cross. But instead of doing 35 times 7, you do 35 times the sine of 7. Is everybody cool? Okay, so let's go back to our notes and let's work this out. In triangle ABC, A is 40, B is 75, AB equals 6. Now, all you guys have trouble with trigonometry when I don't give you the triangle. And I'm confused by that because what do you need to do trig? A triangle, yes? Does the triangle matter how you draw it? No, of course not. The only thing you need is a triangle. It's only there to help you. Done. Now, you got to be smart about it though, right? One of the angles 40, one is 75, and we don't know the third one, yes? Does everyone agree? Okay. Now, 75 is bigger than 40, yes? So which of these angles is it logical for you to name B? Talk to your neighbor if you need to. Where would you put B? 1, 2, or 3? Okay. Who has an answer? Where does it make sense to put B? In number 2, Burke? Why do you think it's number 2? I'm sorry? Because it's most likely the widest angle, or is it the widest angle? It is the widest angle because you know angle C, don't you? Why do we know what angle C is? I didn't tell you what angle C is. So how do you know what angle C is? 180 minus 75 minus 40, right? So we know C equals 65 degrees, yes? Now, Burke has said the widest angle would have to go at 2. Why is the widest angle at 2, Burke? Even in a 90-degree triangle, this works. The widest angle has to be across from the longest side, doesn't it? We knew that from our special triangles, right? So this has to be B, and this has to be 75. Does it matter about the other two? Do you think? No, it doesn't. So it doesn't matter. The way I've drawn this angle looks to be smaller, doesn't it? So for you guys, you're probably going to want to make that A, which makes this C and this 65. Everybody cool? Everybody good? Okay. And what else do we know in this triangle? AB is 6. Where is side AB? Left, right, or bottom? It's right. This is 6. Now, I have called it AB, but what else could I call it? Little c, correct? If I call it little c, can we now use the sine law? Yes, because I have a pair of information, don't I? So, the sine law says A over sine A, B over sine B, C over sine C, yes? So I have C and sine C. So 6 over sine 65 must equal something over sine 75 and something over sine 40. What letter could I put there with 75? Yep. Small b. What letter would I put here? Little a. Because AC is little b. Sorry, AC, yeah, little b. And BC is little a. Now, how do I solve this? Can I do it in my head? No, obviously not. I have to do more work. How do I solve this? 6 sine 75 divided by what? You multiplied the pair and you divided by sine 65. That will get me B. What will get me A? Six times the sine of 40 divided by what? Now, why am I making you write this out? Because you don't need to, do you? You can just do it with your calculator, right? But doing this many signs, especially if you have a backwards calculator, I don't think any of you do, but if you are stuck with using one of those backwards calculators, sine law and cosine law are really hard to do because your calculator does some stuff that makes it difficult, okay? I want everybody to try to tell me what B and C are using their machines. Remember, you need to be in degree mode. So grab your calculators and tell me what the answers are. Wait. Tell me what the answers be. Wait. See if you can tell me what the answers be. You see what I did there? I'm being funny. Hey. You guys. One decimal place is more than enough. Would anybody like to offer one of the answers? Max? Sure. 6.4. And what did somebody get for little c? 4.3. Now let's go over to our triangle and check. 6.4, 4.3. Now, is the biggest side across from the biggest angle? Yes or no? Is the littlest side across from the littlest angle? Yes. Is the middle side across from the middle angle? So are we right? Yes. We are 100% correct. Is everybody cool with this? And this will work on every triangle, including 90-degree triangles. Okay? So let's look at the next one. Who remembers what the phrase solve the triangle means? Yes, means find all sides and all angles. So let's do this thing. What do I know in my triangle right there? I know one angle and two sides, correct? Do I have a triangle yet? No, so I better draw one, right? Does it matter how I draw it? Oops. Everybody happy? Okay. I know one of these angles. Does it matter where I put that angle? No, it doesn't. But I always like to put it down in this corner. Just 'cause. I just find that easier to keep in my head how to draw the rest of it. So if I call that guy 35 and he's D, that makes E and F over there somewhere, yes? Okay. What else do I know right now? If I set this guy as big D, what do I know about this side? It's little d, and do I know something about it? It's 7. What else do I know? One of the other sides is 12. Does it matter which side I make 12? How many people think it matters in the drawing? How many people think it doesn't matter in the drawing? How many people think it'll come out in the wash at the end? Okay, everybody tell me where E is right now. You think about it. You put little e on your triangle. You've got two sides to choose from. You put it on it somewhere. Oh, wait a second while everybody writes 12. It should take literally 1 second. Has everybody put 12 somewhere on their triangle? Excellent. Do not change yours if I put my 12 in a different spot. Do not change yours. Everybody understand? Don't change it. I'm going to put 12 here. I got it right! Okay, if I make that 12, then that makes this side little e, doesn't it? Which makes this side, this angle what? Big E. Which makes this angle big F and makes this side little f. Is everybody cool? Now, some of you drew this triangle. 35, 7, 12. Then you have E and F like that, don't you? Everybody has one of these two triangles on their sheet right now, yes? Everyone? Okay. Now, what do you notice right there? No matter which triangle you've drawn, what do you have? You have a pair, don't you? You have 7 over sine 35, correct? What else do you have? Well, you have 12 over sine E, don't you? Does everyone agree? In both triangles, I have 12 and sine E, yes? Why can I not do anything with F right now? Because you know nothing about F, do you? So I have to work with E. How can I solve this? What math do I need to do? Sine 35 divided by what? 7 equals sine E, correct? Do I want sine E or do I want E? I want sine E, don't I? This will give me sine E, but I don't want sine E, I want E, correct? So what am I going to have to do at the end of all this work? Shift sign. Can I do shift sign at the beginning of it all if I'm good with brackets? You can. A great many of you guys aren't super hot with the brackets on your calculator. So I would recommend you do this first, which will get you a decimal. Once you have that decimal, you can shift sign to get angle F, can't you? So everybody go ahead and do that however you need to. And then tell me what you get. Remember, for angles, we go to the nearest degree. Who has an angle for me? Pardon? 80. Angle E equals 80. Now, you guys, does it matter which triangle I used? So did it matter which triangle you drew? No, because you know that angle E is 80 in both of these. Which means, do you now automatically know angle F? How? 180 minus. So angle F equals 180 minus 80 minus 35, which is what? Max already said it. F is 65. Once you have F, what can you now do? Seven? Oh, I see. You've gone ahead a step, you crazy. Yeah, keep going, Max. What do I now have? Do I still have a pair? Do I have some information about the F's now? F over sine 65 equals 7 over sine 35. Do I know how to solve that? 7 sine 65 divided by sine 35 equals little f. You guys do the math and tell me what little f equals. To one decimal place, please. Actually, no decimal place, because the other one have no decimal places. 11. So F equals 11. Now, check it. Is the biggest angle across from the biggest side? 80 across from 12, 80 across from 12. Is it? is the littlest angle, 35, across from the littlest side? Yep. And is the middle angle across from the middle side? Did it matter how we drew it? As long as we drew a triangle. What if I had put the 35 up top? Would it still have worked? Of course it would have, because the triangle is only there to help you out. Because this is not real life, is it? This is math class. In a real life question, you would have to put the angles in the right spots, wouldn't you? If you're building a bridge, you have to know that the bridge and the wire angle is here. Does everybody understand that? But for practice, when we learn how to use this stuff, it doesn't matter how we draw the triangle. Is everybody cool? All right, you guys are going to try the next one. Oh, wait, I'm done. I can't be done, and yet I am. Excellent. So there you go. Do some work. Now wait a sec. Remember. I don't have a fine tip white. So, do enough to get it, which means on this page, which says it's page 108 from the text, but in your books it's going to be page 171 or whatever. On this page, page 108, do a couple of each. Okay? You don't need to do everything on that page because that's the easy stuff, right? If you get it once or twice, it doesn't change, does it? Just like what we found over here. It didn't matter which triangle we used, it still worked, right? So don't spend a lot of time getting worried about page 108. Okay? But on page 109 and 110 and 111, you're going to want to do some more of those because those are more real life applied ones. Everybody with me? Everybody cool? Now, I can't remember. Yeah, I didn't supply you guys with the answers, which is a little frustrating. I don't know what the heck I was thinking. But no big deal. We're going to spend today and tomorrow on Sine Law. Okay? So make sure today you get a good start on page 108. You got 25 minutes left, right? Go ahead, do some work on page 108. Make sure you're comfortable with it. And I would say do not worry about number 9 at all. Do not worry about number 8 at all. And that's it for now. Do 108 today. And don't worry about 8 and 9. We'll come back after tomorrow, after we have our lesson tomorrow, and we'll spend our time on 1, 9, 10, and 11, okay? Because tomorrow I want to talk about number 9. What oblique right and no triangles means. Why I've skipped number 9 today. Number 9 will make sense after tomorrow. Everybody good? You shouldn't need to take home any homework. You should have enough time, especially because I'm about to shut up, to get really comfortable on page 108. But listen to me. It's the last thing I'm going to say. What we do tomorrow is going to be really difficult if you're not really good at page 108. Do you understand what I'm saying? You need to be good at 108. Just the theory of the sine law. Not applying it yet. We're going to apply it tomorrow, but get good at 108, okay? Go. And like I say, guys, I'm so sorry. My back is already killing me. If you need help, you have to come up here. I'm really, really sorry. Stupid snow.